Hi students, welcome to YouTube channel Maths Guru. Today I am going to explain you logarithms for class 10. First of all, let me define logarithm. What is a logarithm? Suppose a is a positive real number, n is a positive real number, a is not equals to 1. If a is raised to the power x, which gives n, then x is said to be logarithm of n to the base a. When a to the power of x gives the value n, here in this, x is called logarithm of n to the base a. What do you notice, children, here? There is a correlation between exponential form and logarithmic form. Logarithmic form is defined from an exponential form. If a to the power of x is equal to n, then its logarithmic form is x is equal to logarithm of n to the base a. So once again, understand the definition, children. A and n are positive real numbers. A is not equals to 1. When a is raised to the power x, which gives n, then x is said to be logarithm of n to the base a. It is symbolically denoted by x is equal to log n to the base a and read as x is equal to logarithm of n to the base a. Here, logarithms are defined only for positive real numbers, not even for 0. Logarithm of 0 does not exist for any non-zero base. For example, logarithm of 0 to the base 2 does not exist. Anyway, there is a correlation between exponential form and logarithmic form. Logarithms are defined from the exponential form. There is a correlation between these two forms. Let us see. If an exponential form is a to the power of x is equal to n, then its logarithmic form is x is equal to log n to the base a. Children, one thing you must notice here. Both in exponential form and logarithmic form, the bases are same. Here in the exponential form, the base is a, while in the logarithmic form, the base is also a. So do remember that base of the exponential form and the logarithmic form is the same. For example, we know that 2 to the power of 0 equals to 1. Anything power of 0 equals to 1. And also we know that 2 to the power of 3 is equals to 8. And we know that 10 cube equal to 1000. Children, we are well aware of exponential forms. We are new to logarithmic forms, but logarithmic forms are defined from the exponential form. Let us write the logarithmic forms of these exponential forms. 2 to the power of 0 equals to 1. Here in the exponential form, 2 is the base. Let us write its logarithmic form. Logarithm of 1 to the base 2 is equals to 0. Here one thing must notice, base is 2 in the exponential form and 2 is taken in place of base of the logarithmic form, and n value is 1, x value is 0. Substitute in place of x and n in the logarithmic form, we get 0 is equal to logarithm of 1 to the base 2. Similarly, convert 2 cube equals to 8 into logarithmic form. Here in the exponential form, 2 is the base. The same 2 is taken in the logarithmic form as base, logarithm of base 2. and the value of n is 8 and x value is 3. Substitute n and x values in the logarithmic form, we get 3 is equal to logarithm of 8 to the base 2. Similarly, 10 cube equals to 1000. Its logarithmic form is 3 is equal to log of 1000 to the base 10. Base is again here 10. Children, let us do some practice bits. Convert the following exponential form to their logarithmic forms by making use of a to the power of x equal to n implies logarithm of n to the base a equal to x. By making use of this conversion formula, convert the following exponential form to logarithmic form. As you know that 2 to the power of 4 is equal to 16, 4 square is equal to 16, 16 to the power of 1 is equal to 16. Let us write their logarithmic forms. Logarithm of 16 to the base 2 is equal to 4. Logarithm of 16 to the base 4 is equal to 2. Logarithm of 16 to the base 16 is equal to 1. Notice that bases are same in both exponential form and logarithmic form. Here in all these examples, n value is given 16. So here in place of logarithmic form, log 16 is taken in all the three examples. And x values are here 4, 2, 1. So this way we can convert exponential form to logarithmic form. Children, let us convert some of the logarithmic forms into exponential form by making use of the formula x is equal to log n to the base a by implies a to the power of x equals to n. Let us take few examples here. Log 10 to the base 10 equals to 1. Log 100 to the base 10 equals to 2. Log 1000 to the base 10 equals to 3. Let us convert these logarithmic forms into exponential form. Here in all these three examples, the base of the logarithmic form is taken as 10. So we must take 10 as base in the exponential form in all the three examples. 10, 10 power of 1, 10 power of 2, 10 power of 3. The values of x are here 1, 2 and 3. Now taking the values of n, 10, 100 and 1000 one by one, by making use of the formula a power of x equals to n, we can convert the logarithmic forms into exponential form. Children, what do you notice here in all these three examples? Observe the logarithmic forms. Logarithm of the same number to the different bases are different. Here, logarithm of 16 is considered to the different bases 2, 4 and 16. Their values also we get differently 4, 2 and 1. Here, it is an important result that logarithm of the same number to the different bases is different. And also one more result you observe here, logarithm of different numbers to the same bases are also different here. Here in the three examples of logarithmic forms, the base is taken as 10, but the numbers are taken here 10, 100 and 1000 in place of n. and which give the results 1, 2 and 3. That means logarithm of different numbers to the same base are different here. 2 points you have to notice here. They are logarithm of the same number to the different bases are different, and logarithm of the different numbers to the same base are also different. Let us discuss some of the observations. Logarithm of a number to the different bases are different. Secondly, we have noticed that logarithm of the same number to the different bases are different, and logarithm of the different numbers to the same bases are different. One more thing we have observed that logarithm of a number to the same base is 1. Here it is an important result that logarithm of a number to the same base is 1. For example, logarithm of a to the base a is 1. Logarithm of b to the base b gives 1. Logarithm of x to the base x gives 1. That means logarithm of a number to the same base is always 1. One more important result is that logarithm of unity to any non-zero base is 0. Logarithm of unity means 1. Logarithm of 1 to any non-zero base is always 0. Children, let us solve some logarithmic equations. Solve the given equation of logarithm for x value. You are given that log 32 to the base 2 is equal to x, and you have to find that the value of x here in this. You are given that the logarithmic form, which is log x equals to log of 32 to the base 2. We convert this logarithmic form into exponential form, that is 2 to the power of x equals to 32. The base is 2 here. The value of n is 32. Converting the given logarithmic form into exponential form, we get that 2 to the power of x equals to 32. I can write 32 as 2 to the power of 5. Hence we get the value of x is equal to 5 by comparing on both sides, or else if the bases on the both sides are equal, then exponents are also equal. Hence we get the value of x as 5. Let us solve one more sum. Find the value of logarithm of square root of 3 to the base 1 by 3. Let's suppose logarithm of square root of 3 to the base 1 by 3 be x. Now write its exponential form, which we get 1 by 3 to the power of x equal to square root of 3. Since the base is 1 by 3 here, the value of n is square root of 3. On simplification, we get 3 to the power of minus x equal to square root of 3. Further, square root of 3 can be written as 3 to the power of 1 by 2. Hence, we get 3 to the power of minus x is equals to 3 to the power of 1 by 2. As bases are equal on both sides, the powers are also equal. Hence, equating the exponents, we get minus x equals to 1 by 2 and it implies x equals to minus 1 by 2. Now let us discuss some laws of logarithms. We have in our syllabus three important laws of logarithms, namely product rule, quotient rule, and power rule. Let us discuss one by one in detail. Logarithm of product rule, that is, logarithm of a into b to the base x is equals to logarithm of a to the base x plus logarithm of b to the base x. What do you observe here? Logarithm of product of two numbers is equals to sum of their logarithms. Logarithm of product is equals to sum of their logarithms. Log a b is equals to log a plus log b. Let us see second one, quotient law. Logarithm of a by b is equals to log a minus log b. That means logarithm of quotient is equal to the difference of their logarithms, which means logarithm of a by b is equal to log a minus log b. Now the third one is power law. Log a to the power of m to the base x, which gives m into log of a to the base x. Here in this, exponent becomes coefficient of the logarithm. M times of log a to the base x. Once again, product rule. Logarithm of product of two or more numbers is equals to sum of their logarithms. Logarithm of quotient of two numbers is equal to the difference of their logarithms. And the logarithm of a to the power of m is equal to m times of logarithm of a to the base x. By making use of laws of logarithms, let us solve some problems. Expand log 343 by 125 to the base 10. Observe that the given question is in the form of log a by b, where a is equal to 343, b is equals to 125. By making use of the logarithm of quotient law, that is log a by b is equal to log a minus log b, this can be expanded as follows: log 343 minus log 125. I can write 343 as 7 to the power of 3 and 125 it can be written as 5 cube. By making use of exponential law of logarithm, log 7 cube can be written as 3 times of log 7. Log 5 cube can be written as 3 times of log 5. So this way it is expanded by making use of the laws of logarithms. Here we have used quotient law and exponent law of logarithms in this example. Here in this example, you are given an expanded form. Now write its simplified form. That means express the given question to the single logarithm by making use of the laws of the logarithms. you are given that 2 times of log 3 plus 3 times of log 5 minus 5 times of log 2. First we use law of exponent of logarithm. 2 times of log 3 can be written as log 3 to the power of 2, and 3 times of 5 can be written as log 5 to the power of 3. 5 times of log 2 can be taken as log 2 to the power of 5. On simplification, we get log 9 plus log 125 minus log 32. By grouping the first two terms, we have noticed that they are in log a plus log b form. Now by making use of the product law, logarithm of product is equal to sum of their logarithms. This is given as log a plus log b, which is equals to log a into b. Hence, it can be written as logarithm of 9 into 125. Log a into b is equal to log a plus log b by product rule. On simplification, we get logarithm of 1125 minus log 32. Again, it is in the form of log a minus log b. What is equals to log a minus log b? Exactly, it is log a by b by quotient law of logarithm. So which can be written as here log 1125 by 32. So the given question is expressed as a single logarithm, log of 1125 by 32. Now let us discuss one important question. If x square plus y square is equal to 47xy, then show that 2 times of log x plus y is equal to 2 into log 7 plus log x plus log y. Here given that x square plus y square equal to 47xy. By adding 2xy on both sides of this equation, we get x square plus y square plus 2xy is equals to 47xy plus 2xy. Why should we add 2xy here in this? Sometimes we have to subtract 2xy on both sides of this equation. That depends upon the conclusion. What is to find here? 2 times of log x plus y is equal to 2 log 7 plus log x plus log y. Here on the left hand side of the conclusion is log x plus y. To get x plus y, here we have to add 2xy on both sides of this equation. Suppose if there is x minus y, in such cases you have to subtract 2xy on both sides of this equation. That depends upon the conclusion of the given question. You must notice this thing here in this solving such type of questions. Now by adding 2xy on both sides, we get here on the left hand side of this equation x plus y whole square. It is in the form of a plus b whole square, a square plus b square plus 2ab. So it implies x plus y whole square is equal to 49xy. After reaching this step, apply logarithm on both sides of this equation. That means logarithm of x plus y whole square is equal to logarithm of 49xy, taking log on both sides of this equation. After that, apply the laws of logarithms that we have discussed earlier. Here we apply exponential law of logarithm. Log x plus y whole square, it is in the form of log a to the power of m, which is equal to m times of log a. So it would be equals to 2 times of log x plus y is equal to log of 49xy. Further, log of 49xy can be written as log 49 plus log x plus log y. That means logarithm of product is equal to sum of their logarithms. Here product of 49 x and y. By making use of the product rule, logarithm of product is equal to sum of their logarithms. Write logarithm of 49, logarithm of x, logarithm of 19 y and their sum. That means log 49 plus log x plus log y. And then I can write 49 as 7 square. Hence we get here log of 7 square plus log of x plus log of y. Again using the exponential law, we get 2 times of log 7 plus log x plus log y. Hence it is proved. Thank you students. Keep watching Maths Guru YouTube channel regularly and get well knowledge about the subject.